My name is Trevin Whiteley, and today I'm going to be looking at the flight path of a bird, the red-breasted nuthatch. So, looking through our textbook, I found this question about gravitational potential energy, and it relates here to a man walking up one of the tallest mountains in North America, starting at one of the lowest points in North America, which is a little bit out of the scope of my abilities. So I decided to essentially apply the same principles to a tiny little bird that I found in my backyard. So the question that I've decided to answer is, how much potential energy does a specific red-breasted nuthatch gain in its flight from a tree perch to the feeder in my backyard? So I figured I'd begin this presentation by introducing my lab assistant, Sitta canadensis, the scientific name for the red-breasted nuthatch. They're small passerine birds, perching birds, about 11.5 centimeters from tail to beak tip. They're sexually dimorphic, which means that the male and female look different, but it's primarily just a plumage thing. Of course, inner biology is different as well, but the mass is going to be about the same for both of them, which is 11.2 grams on average, and this is the mass I will be using. But I am going to be using an adult male subject, so I can be certain about the dimensions. The materials I'm going to have to use are, 1, the gravitational potential energy formula, of course. I'm going to have a bird, male Sitta canadensis bird. I'm going to need a bird feeder, bird seed to attract my bird, a camera to record everything. I'm going to have a tape measure so that I can measure the height of my banister on my deck to establish some kind of reference for Logger Pro. I'll need iMovie in order to edit the video and make the bird stand out a little bit. And then Logger Pro is going to help me determine pretty much all the data. So I'm going to start by filling the bird seeder with seed. Then I'm going to wait for one of my nuthatches to approach the seed feeder and record a video of that. Then I'm going to have to go into iMovie and raise the contrast so that I can easily pick out where the bird is, and that way I can import it to Logger Pro, track the bird's movement. This will allow me to gather the data required to perform the calculations that will allow me to tell the story of the red-breasted nuthatch's flight in terms of gravitational potential energy. And here I've decided to show a slowed down video of the bird's flight. You'll be able to see that it's very hard to actually make out, so it took a bit of sleuthing on my part. But you can see more clearly the bird's actual ascent to the feeder. Here's all the data that I acquired. On the left hand side I have a list of the various different y values. So this is the height of the bird, and here I'm going to pick out maximum and minimum values as well as start and end values. And on the right side, the blue dots represent the y value, so the height of the bird. You can see that it starts higher than it ends, and there is that minimum point partway through. And the x value is represented by the red, and you can see that it slows down substantially near the end.
Time to do some math.
Now for my calculations, I of course need at the top the energy equation for gravitational potential energy. Then I have on the far left, I'll just do this left to right, I have my initial height, my minimum height, so that's the little crest at the bottom, or the trough rather at the bottom, and then the final height, as well as the other two values that I'll need, so the acceleration due to gravity on Earth and the mass of my bird. Now here I've plugged the first value into the equation. As you can see, I've multiplied all the values out, and then I'm given 0.38 joules. So this is the initial gravitational potential energy of the bird. Next, I calculated out the minimum gravitational potential energy of the bird, and that turned out to be 0.252 joules. And here I've calculated out the final gravitational potential energy of the bird, which is 0.311 joules. So at the top here, I have found out how much gravitational potential energy was lost over the entire course of the flight. So I subtract the final gravitational potential energy from the initial gravitational potential energy. It's a term I'm getting tired of saying. So the result there is 0.069 joules were lost over the entirety of the flight. And now I calculated next, right below that one, the amount of gravitational potential energy gained after the minimum value was reached. So on the ascent, how much gravitational potential energy did the bird increase its gravitational potential energy by? And that turned out to be 0.059 joules. And I arrived at that by starting with the final value and subtracting from that the minimum value. And after that, I calculated the amount of gravitational potential energy that was lost between the maximum and minimum. So this is that first stoop, starting at the maximum value at the very beginning and ending at the minimum value in the middle. So I just subtracted the minimum value from the maximum value, and that turned out to be 0.128 joules, or in proper significant figures, 0.13 joules. So what does this all mean? Well, it would seem that my little birdie began his flight by converting 0.13 joules of potential gravitational energy into kinetic energy. And of course, while doing this, some of that energy was being lost to drag. And then after that, he ascended to the feeder, so he converted some of that kinetic energy back into gravitational potential energy, 0.059 joules of that. And so the total gain of energy was actually negative. He lost energy in doing this, 0.069 joules to be precise. So hopefully the bird grabbed enough nuts that this minor joule loss was accounted for and made up for. That's all. Thanks for tuning in, and I'd like to thank Carrie Kirschbaum and Kara and Knight Randall Dewey et al. Yeah, for helping me, giving me information so I could do this. Thanks, guys.